again and welcome back to our functions lessons, and in this lesson we are going to determine the equation of a parabola. Now remember, in grade 10 parabolas are of the form y equals ax squared plus q. It's a quadratic function. Now, when we have the y-intercept and any other point on the function, so we have the y-intercept and any other point, and we want to determine the equation. So first of all, if we know it's a parabola, I know its function f, so this will be fx equals, and remember fx is the same as y, equals ax squared plus q. Now what is it that we want? We want to know the value of a and the value of q. Now our first step is put in the y-intercept. So this will just be equal to, and I'm just going to, for simplicity, write y. So y equals ax squared, and what is q? Plus 3. Okay, brilliant. And there we go. And just like with linear equations, we go to the other point. And I'll circle that in blue. This is our other point. So the x goes into x's place and the 7 goes in y's place. So that 2 goes into x's place, the 7 goes into y's place, and then we can solve for a. So let's see what happens. So this is 7 equals a, and in the place of x we have 2 to the power of 2 plus 3. Okay, normal substitution, right? And then this will leave us with 7 equals, and then 2 to the power of 2 is 4, so it's 4a plus 3. And then we take the 3 to the other side, becomes a minus 3, so 7 minus 3 is 4. 4 equals 4a, and then we divide with this coefficient, so it will be 4 divided by 4 equals a, and therefore we know that a is equal to 1. 1 equals a. And there we go. So now I've got the a and I've got the q. So what is my function? And I will write it over here. So my true function is fx equals a is 1, so 1x squared, and what is my q? That is the 3, we know that, so it will be plus 3. Let's just go make sure. It's a positive a, legs are pointing up, plus 3, that's where it starts on the y-axis, and we are done. Okay, excellent. Really easy, isn't it? Put in your y-intercept, substitute the other coordinate point into x and y, and solve for a, and write your entire function. Now, how about the next one? When we don't have the y-intercept. So here's a little bit of a trick and a tricky part. So please remember this. It's quite important that you do so. So when we don't have the y-intercept, but we have the x-intercepts and another point. Very important, we need both the x-intercepts. So in grade 10, they sometimes leave out this one, but if that's minus 2, then this one will be 2, because you know that the line of symmetry that divides my parabola into 2 in grade 10 will be my y-axis. So if that is a minus 2, this will be 2. If this is a minus 3, that will be 3, because in grade 10, we don't have left and right movements. So here we go. Now, if we have the two x-intercepts and one other point, I cannot, and I'll show you quickly, if this is my function, y equals ax squared plus q. If I don't have the q, but I put that 1 into x's place and the 6 into y's place, I also don't have a. And because I have two variables, I cannot solve for any one of them, right? So what I need to do is I need to memorize the following formula. So please pay attention to this one. I am going to use a factorized version. So y equals a, and then in brackets I will say x minus x1, and then x minus x2. Okay, so that is basically what I'm going to do now. So this is just a factorized version of this normal function, and you have to memorize this, and I'll put a star there. When do we use this one? When we don't have the y-intercept, but we have the x-intercept and another point on the parabola. So first of all, we need to know what is this x1 and that x2. They are my two x-intercepts. So x1 and x2, and I'll do that in purple to show you, this x1 and this x2, they are my x-intercepts. Okay, so please don't forget that they are my x-intercepts. And I'll show you in a minute what we do next. So the x1 and x2 are my x-intercepts. Now, what we do next is we take that other point, and I'll circle that in green. So we take this point and we substitute in that 1, which is the x, into that x's place and that x's place, because the x and the x is the same, right? So 1 goes into that x's place and there. So I'll draw a line that goes in there and it goes in there, okay? And then the y, the 6, goes into the y's place. Okay, brilliant. So let's just rewrite that. So this is now 6 equals a, and then we have 1 minus, and what is my first intercept? It doesn't matter which one we put first. Let's make it minus 2, so that will be minus 2. And please leave it in brackets because a minus and a minus will give me a plus later on. And then we have the 1 again, which goes into x's place. So there's the 1 minus, and what is my other x-intercept? It's a 2. So that just stays a 2. And there we go. So now we have the following. This will be 6 equals a, and then in the bracket here, 1 minus minus 2 becomes 1 plus 2. That will be a 3. And in this one, 1 minus 2 is a minus 1. Okay, great. So let's just multiply this out. So now I have 6 equals minus 3a. And now I can solve for a normally by dividing with this coefficient. So 6 divided by minus 3 equals a. And then we have minus 2, which equals to a. And now I've got my a. So from here, what do we do next? I write my function, which is y equals minus 2x squared plus q. And now I still need to get my q. And what do we do now? Again, we just take that other point there and we substitute it in here. So again, the 1 goes into x's place and the 6 goes into y's place. So let's do that. So the 6 goes into the place of y, and then minus 2, and the x is a 1 plus q. And this gives me 6 equals minus 2 plus q, so 8 equals q, because if I move that minus 2 to this side, it becomes a plus 2, and 6 plus 2 is 8, and my q is 8. So what is this entire function? I'll write it here at the top in purple. It will be fx equals, what is my a? Minus 2x squared. What is my q? Plus 8. And let's go and see if we are correct, because we can kind of see whether we are, because the minus 2 tells us that the legs are pointing down. Yes, they are. And then plus 8, that is up here, and it's higher than the 6, right? Okay, because 6 is over there, that's 8, so we can kind of see that we work correctly. And that is all there is to it. So what do you have to remember if you don't have the y-intercept? We use the factorized version of the quadratic function, which looks like this. Please don't forget, x1 and x2 is my x-intercepts irrespectively, and that x and x is the same x, which is just the other point's x-coordinate, and the y is the y-coordinate of that point. And then we solve for a. And once we have a, we put it into the equation, and then we use that same point, substitute in the x-coordinate and the y-coordinate again to find the q, and then we have our function. Now let's go and try some more examples. Now here are 2 examples that you can try. Give them a go, and once you are ready, resume the video to see if you are correct. Okay, here I go. Determine the equation for each of the following functions. Well, this is a parabola, and we know in grade 10 that our parabola is of the form y equals ax squared plus q. Okay, now I already have my q, so let's put that in. Y equals ax squared minus 8. And now I need to calculate A. So I can use any other point except the one that I used for my y-intercept. So any one of those two. Okay, so easy enough. I can just use the 2. And what are the coordinates there? It is 2 and 0. So there's my 2 coordinate points. Take that 2, put it in the x's place, take the 0, put it in y's place, and then it will look like this. So 0 equals A, in brackets 2 to the power of 2 minus 8, and then I have 0 equals 4A minus 8, and then I know minus 8 goes to that side, it becomes 8 equals 4A, and 8 divided by 4 is 2 equals A. And then my function is, let's say it's function f, so fx equals 2x squared and minus 8. And let's see if we are correct. Because it's a positive A, the legs are pointing up. Because it's minus 8, it starts at minus 8, and there we go. Now, just for interesting sake, let's see how they went from the function to drawing that parabola. Now, there's a little thing that you can pay attention to. We did this in the previous lesson, but I like to show you again. So, when we want the y-intercept, we already have it. It's minus 8, so we plot it. There's the minus 8. Now, to get the x-intercepts, we have to make y 0. And I'll do this up here, okay? So, then we have 0 equals and 2x squared minus 8. Okay, great. Now, because this is an equation and I can see there's a common factor 2, well, we're not going to take out the common factor when there's an equation. I'm just going to divide with 2 to get this simplified. So what I do is I'm going to divide with 2. So 0 divided by 2 is a 0 equals, and then 2x squared divided by 2 is just a x squared. So there we go. And minus 8 divided by 2 is a minus 4. And now we've got 0 equals x squared minus 4. That is a difference between two squares. So now I have 0 equals, and that's x minus 2, x plus 2. There we go. We've got a 0 product rule. So therefore we can say x minus 2 equals 0. So x equals 2. Or we can say x plus 2 equals 0, so x equals minus 2. And there is my two x-intercepts. Plot the 2, plot the minus 2, and there we go. So can you see? My original function still stays 2x squared minus 8. But when I made the y 0, this became a normal equation. I can divide with 2, or I can take out a common factor 2. And if I did, we just simply take 0 divided by 2, and that 2 will fall away because we have to divide with the coefficient. But I don't usually do that. I just see, well, if there is a common factor in the numbers here, then I just divide with it straight through. I get the simplified version, and then I can do my factorization. Okay, nothing new to you. We did it in quadratic equations, and that is how they drew it. Now, how about the next example here? Again, they didn't give us the y-intercept, so that becomes a little bit of a problem, because if we say y equals ax squared plus q, and we don't have q, we also don't have a. So even if I take that point and put it in the place of y and x, I still have two unknown variables, so I cannot solve for one. So here I have my two x-intercepts, so I'm going to use the factorized version of this equation, which is y equals a in brackets x minus x1 and x minus x2. There we go. And now what do? I identify my x1 and x2, which is minus 4 and 4. They are my x-intercepts, right? Okay, let me show you in purple. There's my first one, there's my other one. And then what is this x? It's my minus 1 of my other point. And what's my y? It's that 15 of that same point. So let's do the substitution then. So my y is 15. Where did it come from? That other point's 15 goes into the place of y equals a, and then what is my x of that point? Minus 1, so put that in. This is minus 1, and then minus, and this x1 is a minus 4, so it will be minus a minus 4. So this will stay minus 4, and leave that in brackets, and close the bracket off. And then what is x again? It still stays a minus 1, it's still the same point, and then x2 is a 4, so it will be minus that 4. And let's close the bracket. There we go. And now what do we do next? We just simplify. So this will be 15 equals a, and in this bracket minus 1 plus 4, that gives me a plus 3, so this will be a 3, and in this bracket we have minus 1 minus 4, which will be a minus 5, and then we have 15 equals minus 15a, and 15 divided by minus 15 is a minus 1 equals a. So now I have my a, which is minus 1. Now let's go and put that into our function. So that means y equals minus 1x squared plus q. And now we still need to find q. So we take that same point, we put the x into x's place, we put the 15 into y's place. So let's do that. So this will be 15 equals minus 1 times minus 1 squared plus q. And let's see what we end up with. So let's simplify. This will be 15 equals, and then minus 1 squared is a 1. 1 times minus 1 is a minus 1 plus q. And then 15 plus 1, because that minus 1 goes to this side, it's the constant. It becomes 16 equals q. So now I know what my q is, I know what my a is. So my function will be fx equals minus 1x squared plus 16, and we are done. Excellent, isn't it? Okay, so it's not that hard. You just have to remember, if you don't have the y-intercept, use the factorized version of the equation, right? And there we go. Let's see if we are correct. A is a negative, legs are pointing down. 16 is my y-intercept. Well, that point is a 15. The y-intercept is higher than 15. It is 16. And there we go. And I hope to see you again soon. Keep practicing. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.